Hello everyone, welcome back to my channel Cloud Up with Gagan. This video will cover the ultimate roadmap to become a DevOps engineer and also SRE and Cloud Engineer. You might be wondering why a single video for all of these three. So it's because all these three roles share a strong foundation. All these three involves managing infrastructure, automating workflows, ensuring systems reliability, and all of these three rely on similar kind of tools and platforms. So following up just one roadmap will not only save your time, but it will also make you versatile. Once you build a solid foundation, and you will have the skills to adapt to any of these three fields. So it gives you freedom to choose your career path. And, it's like learning the basics of cooking. You can later specialize in any of one field like baking, grilling. I don't know much about cooking, but it all starts with mastering the essentials. My goal here is to simplify the learning process for you. No complicated jargons and no words that doesn't make any sense for beginners. So I'll be keeping everything very simple. A lot of videos and articles over internet, it says like DevOps, SRE, all of these roles are not for beginners. But I don't 100% agree with this. If you're a fresher or a beginner with these technologies, you can definitely start your journey. So I can say you won't get directly a role for a senior DevOps engineer or an architect, but there are plenty of entry level positions like junior DevOps engineer, junior infrastructure engineer, and DevOps support engineer. These roles are designed to help you get started. In these positions, you'll work under experienced seniors, gain exposure to real world challenges, and learn on the job. That's how every career works. You start at the basics, build experience, and grow. So don't let anyone discourage you. If you are ready to put your efforts, you can definitely kickstart your career, even as a beginner. So don't worry. Let's understand in very easy language what is DevOps. So there are two key teams that are involved in releasing a software or an application. So one is development team, the second one is operations. There are a lot of other teams also, but yeah, let's just talk about these two main teams. So the development team is responsible for writing the code, building the application, like the real software logic. And the operations team, it's responsible for deploying and maintaining of that application software. So traditionally, these two teams often worked separately, which could cause delays and misunderstanding. That's where DevOps engineer comes in. So it acts like a bridge between these two teams, development and operation. That's why it's called DevOps. Their role is to ensure that application isn't just deployed successfully the first time, but also every time for every future update and change in a continuous and automated manner. And just like that, SRE or Site Reliability Engineering, it's all about making sure systems are reliable, scalable, and they perform well. So, reliable means the systems you can rely on, and scalability means the systems that can grow and handle more load as you need it. So, their focus is to keep everything up and running, not just running smoothly. Similarly, a cloud engineer designs, set up, and manages the cloud infrastructure that supports applications and services. So, all right, let's break this down. Let's break this roadmap into two rounds so you can follow along and build your skills step by step. The first round is all about gaining exposure to a broad range of technologies and setting up understanding how everything works together. I want to make it clear it's not just basics. Like the first round is not just basics, but it's also not so advanced. So this will help you to avoid getting stuck on just one thing and then feeling demotivated and then stopping everything, right? So the idea is to get a solid foundation across the key areas. So you can then prepare for anything. Let's start with step one of first round. Step one is for building a strong foundation by deepening your understanding of Linux and networking. In the prerequisite video, we have covered all the basic topics. Make sure to watch that video. Most of the servers and also the tools we need to work with runs on Linux. So it's must-have skill. Let me mention those basic topics again, along with more advanced concepts. Let's start with basic bash shell usage. That includes navigation commands like cd, ls, mv, cp, and then permission management, chmod, and chown. Process management, ps, kill, top. Networking commands like netstat, ping, ssh, telnet. Like you need to know how to connect to remote servers. Then package management like yum and apt. So you need to know how to install software packages. And some more commands like cat, echo, top, tail. And now some more advanced topics like text manipulation commands, awk, sed, grep for searching and filtering and processing text. Like these are very helpful for scripting also. Then cron jobs, these are helpful for scheduling tasks at specific times. Disk management, fdisk, mkfs, these are used for partitioning and formatting disk. Users and group management, user add, user mod, password. So these commands are useful for managing users and groups. Log management, log rotate, security like IP tables, UFW for configuring firewalls and managing network security. But actually, Linux is not limited to these only. As you will start working with Linux and all these commands, you will see new commands and topics unfolding. Step two, it's bash scripting and Python basics. Once you have got a good grasp of Linux commands and networking, the next essential skill is automation. And to do that, we'll be using bash scripting and Python. At this stage, it's just basics. Both are incredible important as as they help you to automate tasks and make your work much more efficient. You'll spend a lot of time automating things as you grow in your DevOps journey. So let's break this down into two parts. Let's see what is bash scripting. Just understand it like writing a series of commands in a text file to automate system tasks. It's like it helps to make your work faster and also less error prone. Here are the core concepts to focus on for bash scripting: variables and basic syntax, conditions, if else to make decisions like based on conditions, loops, for loop, while loop. So it's used actually to uh, you know to do something multiple times, like for iterations. And then functions for reusability, and then error handling and logging to handle if an error occurs and to see that status in the logs. These concepts are critical. These concepts are critical for automating your work and improving productivity. So, while bash scripting is great for automating system tasks, Python is a very powerful language. So, so that you can use for more complex automation. So at this stage, we just need to learn basics of Python. I don't want you to get stuck anywhere. You know, keep moving, keep making small steps rather than just stucking or stopping at somewhere. So these are some, not some. These are the same topics that you need to use with Python: variables, conditions, loops, function, error handling, and logging. Bash scripting and Python are going to be very helpful for you to handle a wide range of automation tasks. Step 3 is version control system. Let's talk about version control systems and the most important one, Git. It's the tool you'll use to manage your code, collaborate with your team, track your code's history, and keep everything in sync. Git is a distributed version control system, which means you can manage your code locally and then push changes to a remote server, like when you are ready with your code. And then GitHub and Bitbucket are the most powerful platform where we keep our code stored in repositories, whether it's for system configuration, scripts, or application code. It makes collaboration with other team members and tracking super easy. Now, let's move forward with core concepts to cover for Git. Um, let's start with Git basics like clone, commit, push, pull. Learn how to work with repositories, add new changes, and push them to remote servers. And then branching and merging. Understand how to create and manage branches for different features or tasks, and then merge them back to main project. Okay. Now, the usage of GitHub and Bitbucket. So you need to get hands-on experience with these. Uh, Try to create repositories, make pull requests, and collaborating with the others. These platforms also let you track issues, discuss code changes. So it's more than just storing a code. It's like about collaboration. Mastering Git and GitHub is must in your DevOps journey. Step 4. Let's now jump on cloud. Okay, let's now jump into the world of cloud computing. So, cloud computing is like renting a super pod computer in the sky, except it's actually not in the sky, it's on the internet, placed at some other place, so provided to us on demand by service provider. There are many cloud providers out there like AWS, Google Cloud, and Microsoft Azure, but I'd prefer you to learn AWS at that stage. You know, because it's the most powerful, it's the most popular and widely used cloud service provider. So, understanding the basics of AWS, it will give you a strong foundation in deploying and managing applications on the cloud. There are like hundreds of services that AWS provide. For example, like from cloud computing, there are hundreds of services that AWS provides, from computing power, storage, and databases to machine learning, analytics, and much more. But we'll just focus on core AWS services that you need to get started. Core topics to cover are EC2. EC2 is like renting a virtual computer in the cloud. You can use it to run websites or applications without needing your own hardware. S3 S3 is a place to store your files. It's like an online hard drive. IAM helps you to control who can do what in your AWS account. It's for managing user groups and permissions. VPC a VPC lets you create your own private network in the cloud. It's like building a private section of the internet just for your services. RDS. RDS is a service for managing databases like MySQL, Postgres. There are a lot other services. There are other databases also. Without worrying about setting your RDS is a service for managing databases like MySQL or Postgres without worrying about setting your own hardware and setting up servers and all. Then CloudWatch. CloudWatch helps you keep an eye on how your services are working. So basically, it's for monitoring. Step 5. Step 5 is basics of Docker. Docker is a tool that actually provides containerization. You may have heard about Docker a lot, but we need to understand what is containerization. So let's take a moment to understand what containerization is and why it's so important. For example, when we deploy an application on a server, there are a lot of things that we need to set up. For example, installing different software, configuring libraries, a lot of other dependencies, and ensuring like everything the app need that's and ensuring that everything the app needs to run is present. But here's a challenge. Doing all this on multiple servers can be tricky. Let's say when you deploy your app on one server, everything works perfectly. But when you try to deploy it on another server, boom, it doesn't work. Maybe you missed installing a certain dependency, or maybe you installed different version of something. Maybe that's not supported. So containerization actually solves that problem. With Docker, we package everything an application needs to with Docker, we package everything an application needs to run, like code, dependencies, libraries, configuration, everything in a container. So we package everything in a container. The best part is the container runs the same way everywhere, whether you're deploying it on like on your local machine or anywhere, remote server or any other server. The app will behave exactly the same. In other words, Docker helps to eliminate the problem. Which problem? It works on my machine. So, here are core concepts that you need to cover. What is containerization? What is Docker? I've just talked briefly about it, but you need to go a bit deep into that. So, and then Docker images and containers, then basic Docker commands like Docker pull, Docker run, Docker PS, Docker stop, Docker build. And then you need to understand what is Docker file. So basically it's Docker file is used to define basically basically Docker file is used to define what your Docker image will contain, like how your Docker file looks like, how your image looks like. Step 6 is all about taking our containerization skills to the next level, starting with the superhero of DevOps, which is Kubernetes. Containers are great, but actually, we need something that can help us to deploy, scale, manage the containerized application. For all that operations, we need something that's Kubernetes. In this step, we'll focus on a basic of Kubernetes to help you get started. So the core topics that you need to cover are what is Kubernetes, and then Kubernetes architecture, then pods. Pods are like smallest deployable unit in Kubernetes, and then nodes. So nodes are any physical or virtual machine that runs your containers, like that are for your Kubernetes cluster. And then what is Kubernetes cluster, and then namespaces, and then you need to know the basic usage of kubectl commands like kubectl get pods, kubectl run, kubectl describe, kubectl apply, and then you need to know about what is a deployment in Kubernetes. So uh, learn how to deploy simple applications on Kubernetes using YAML files, and then Kubernetes service. So learn how to create and manage services to actually expose your applications. So this should actually give you a solid foundation in Kubernetes. Once you are comfortable with the basics, we'll dive into more advanced topics in our second round. Step 7 is basics of CI/CD. It's time to talk about CI/CD, continuous integration, and continuous deployment, also continuous delivery. This is a step where we automate the entire flow from end to end, ensuring that every change we made in our code base is tested, built, and deployed automatically without any manual intervention. To get started with CI/CD, I recommend diving into Jenkins, which is one of the most popular and easy to use tool for building and automating these pipelines. So the core topics that you need to cover are what is CI/CD and what are various CI/CD tools. There are a lot of other CI/CD tools in the market, which are also very popular and even more powerful than Jenkins also. Okay, but for our scope in this step, we will just cover Jenkins. So next, the topic is how to set up Jenkins. and then understanding the stages in a pipeline like build, test, deploy. Then connect Jenkins to GitHub and then try to create a freestyle project and deploy a sample and simple application. And then try to set up automated build triggers and create a pipeline with basic steps to build, test, and deploy. This will give you an understanding like about the whole concept. This will actually give you an understanding about the whole concept of CI/CD. Step 8 is basics of Terraform, and it's the last step in the first round. Let's level up the game by creating everything using code. This step is all about infrastructure as code. We also say it like ISE, and in our case, we'll use Terraform. When we work on big environments, we can't just create everything manually, which is error prone and also not reusable. Instead of setting up servers, networks, and other sources by hand, we can define them in code. So it actually makes it easy to deploy, scale, and also in maintaining our infrastructure. It also reduces human error, and it ensures consistency. And you know it also helps us with version control because we'll be keeping our like all of our code in some version control system like it. At this stage, we need to cover like how to set up Terraform, and then Terraform topics like what is provider, what is a resource, and how to write provider and create infra using resource blocks. Try to set up S3 bucket and EC2 instances, and then load balancer with ISE with Terraform. So the other like some more topics are what is Terraform state and how to use that Terraform state. And you need to know about all the commands like Terraform init, Terraform plan, Terraform apply, Terraform destroy. This will help you to understand the actual power of infrastructure as code. Okay, so you should be feeling empowered now because you have come a long way, and congratulations. We have covered a lot, and the best part is you probably didn't even notice how far you have reached at this stage. That's because everything is designed to gradually increase in difficulty, keeping you motivated and confident as you achieve results at every step. So, congratulations again. Let's start with round two to gain more interesting, exciting, and advanced skills. Step one is diving deeper into Python. By now, you have already got the basics of Python under your belt from round one. But here's the exciting part, this step will take your Python skills to a whole new level. We are not we are not looking at Python as a programming language for development, but as a powerful tool for automating and scripting to solve real world problems and efficiently. The topics that you need to cover: advanced Python concepts, writing and using functions effectively, working with modules and libraries like OS and sys for system level tasks, error handling with try except blocks, regular expressions for text searching, matching, etc. And then some automation focus skills like file manipulation, reading, writing, renaming files, data processing using Python scripts to clean and transform data, and automating repetitive tasks like sending emails, managing files, or performing system checks. I prefer you to do a mini project, like create a Python script that reads a directory, rename files to include a timestamp, and logs the action to a text file. So let me give you 3 steps for this. Like use the OS module to list all the files in a directory and then loop through each file and append the current timestamp to its name. Write the log of changes into a separate file like any change.txt or any. With Python as your automation powerhouse, you'll be able to handle tasks that make life easier and your workflows smoother and efficient. This is where scripting meets creativity. So let's get coding. Step 2 is advanced cloud computing. You have already dipped your toes into AWS in round 1. This is the time where you have to strengthen your cloud computing skills and take it to next level. These skills will help you design scalable, secure, and highly available cloud environments. Here is the list of topics that are must to cover. In identity and access management, you have to cover policies, roles, cross account access, and managing least privilege. In networking, you have to cover advanced VPC design with private link, transit gateway, and VPC pairing. And then NLB and also AWS WAF for security. Now, moving towards storage options, you have to cover S3 and further the concepts for S3 like lifecycle policies, versioning, intelligent tiering, and cross region replication. EBS, snapshots, and encryption for EFS, advanced access patterns, and scalability options. Now, for monitoring and logging, you know, CloudWatch, but you have to deep digger into like custom metrics, setting alarms, dashboards, and then in CloudTrail, you know how to do auditing, you know how to read the audit logs. And then AWS config for compliance and automation. And the next part is databases. So you know how to use RDS with multi-AZ and read replica options for high availability options. Then DynamoDB for global, and then DynamoDB on-demand tables, global tables, DAX, like all of these for caching, and Aurora for serverless architecture and global databases. Now, scalability and availability, Elastic Beanstalk, auto scaling groups, ELB, and Route 53 for routing and DNS. Moving forward, serverless computing, AWS Lambda. Lambda is one of most important service, so make sure not to skip this. Event-driven architecture with API gateway integration and then step functions. So, and then for containers and orchestration, ECS is Elastic Container Service, actually one of a container management service provided by AWS. And then EKS is Managed Kubernetes Service by AWS. So then infrastructure as code, uh, for which you need to learn CloudFormation. In CloudFormation, you need to know how to use nested stacks, custom resources. So CloudFormation is actually AWS native infrastructure as code tool. Uh, Moving forward, okay. Now, disaster recovery and backup. You know how to use AWS backups, like it's a centralized backup management service from AWS, and also cross-region replication and point-in-time recovery. Step 3, it's time to dive deeper into the container world and unlock the real power of Docker. You have already know about what containers are and how containers work. We'll now explore advanced concepts like that enable you to create efficient and scalable solutions. The topic that you need to cover are Docker networking, Docker volumes, and security in Docker, multi-stage builds. So it's for optimizing Dockerfile for smaller images and faster builds. Then Docker Swarm, it's optional. Um, it's up to you if you want to cover. And then Docker logs and monitoring and container optimization, like how to reduce image size, how to manage your sources, all that stuff. And then do a mini project to deploy a multi-container application using Docker Compose. So for this, you have to create a compose file for simple application stack like front end using Nginx or Apache, and then back end using Python, Flask application, um, database using MySQL, and also define networks and volumes to make this whole application, having persistent storage for the databases. Step 4, let's conquer the superpower of orchestration with advanced Kubernetes concepts and dives into managing it on AWS EKS. Don't get overwhelmed. Okay, you are almost there. You have come such a long way, and by now you should feel very confident in how much you have accomplished. Give yourself some appreciation and celebrate. So, the core topics to cover are stateful sets, daemon sets, config maps, secrets, HPA, and VPA, which are horizontal port scaling and vertical port scaling, network policies, custom resource definitions, we also call it CRDs, and RBAC, role based access control, and then monitoring and logging. So after this, try to use Kubernetes on AWS EKS. Not actually try. Use Kubernetes on AWS EKS. Set up a EKS cluster from scratch, and then try to deploy applications on there. Cover all that stuff on EKS. So I'd say do a mini project to deploy a scalable web application on AWS EKS. Let me also provide you, few step-by-step guide for this. So the first thing is you have to set up a cluster. Use AWS CLI or console to create the cluster. I would suggest you to use CLI and then configure kubectl, which you may have already configured because you're already using Kubernetes at this point. So next, deploy a sample web application and also try to um, play around with HPA, VPA. So, and within this exercise, you should be using AWS RDS for database and also CloudWatch for monitoring. So the last thing is um, configure scaling. So enable auto scaling for pods and also cluster autoscaler like for nodes and all. By mastering Kubernetes advanced features and leveraging AWS EKS, you'll be ready to handle large scale production grade deployments with confidence. Step 5, it's advanced Terraform and Ansible. Round 2 is all about enhancing and leveling up the skills. So is what we need to do with ISE. We need we need to dive into advanced Terraform topics and also start with Ansible. So Ansible is actually a configuration management tool that allows us to create playbooks, you can say like scripts, to do anything automatically across multiple servers at once. You don't need to do everything manually on each server. So it actually helps to save time and reduce human error. Okay, so let's start with advanced Terraform topics. The first one is Terraform modules. Uh, so you need to know how to use Terraform modules to create reusable Terraform code, and then state management, then workspaces, and then data blocks, and finally Terraform Cloud, like enterprise solution. So explore how to use Terraform Cloud for remote execution, collaboration. So, and for Ansible, you need to understand what is like you need to understand what are Ansible playbooks, how you define tasks there to execute on remote systems, and then inventory modules, and then roles. Step 6 is CI/CD advanced and GitOps. It's right time to master CI/CD now, and it's also not new for you because we already have understanding about what is CI/CD and how it works. Let me introduce one more important topic, GitHub Actions. It is widely used for automating workflows, and it's something you'll definitely want to start using as well. With GitHub Actions, you can automate everything directly on GitHub itself. So GitHub Actions is a feature in GitHub that allows you to automate workflows for your project. It helps you run tasks automatically, like when a certain event happens. For example, like when you push code to repository, or when you create a pull request, it automatically triggers the workflow. Okay, so let's now cover the topics that you need to cover for CI/CD concepts. Um, Start with creating complex pipelines with multi-branch support, and then start creating Jenkins file, and then try to integrate Kubernetes and cloud platform with your Jenkins. Next part is you have to automate infrastructure provisioning using CI/CD. So you can integrate Terraform or CloudFormation to start provisioning the infrastructure, but using CI/CD. Now for GitHub Actions, start with creating infrastructure using GitHub Actions. Like for example, try to create infrastructure using Terraform, or just directly with some Python code or bash scripting, but by using GitHub Actions. Um, then gradually start using GitHub Actions more with the same things as you use with Jenkins. I would suggest you to do a project to do everything you have learned so far by using CI/CD. So first do it with Jenkins and do the same with GitHub Actions. Try to create a sample web application, which you may already have now, because we have used it multiple times. And then set up CI/CD pipeline on Jenkins, and you know um, and then containerize the application using Docker. Push the Docker image to container registry, maybe Docker Hub or ECR, depends on you. And then create Kubernetes cluster on AWS EKS, or you can use your existing EKS cluster also if you already have. Then deploy the app to Kubernetes cluster, and next part is implement deployment strategy like blue, green, or canary. Set up monitoring and observability using Prometheus, Grafana, or whatever monitoring tool you like. And in the final step, try to integrate the steps for automated rollback and also scaling. Once you are done with the exercise on Jenkins, replicate the same thing on GitHub Actions. For the last step, the step 7, will dive into observability and monitoring, which is especially critical for SREs to ensure systems run smoothly and issues are detected early. It's the backbone of SRE. As an SRE, your goal is to ensure systems are reliable, and this step helps you monitor, track, and maintain the health of systems that you manage. The core concepts. The core concepts to learn: Prometheus, and then Grafana. Grafana is used for visualizing metrics and creating dashboards. And then alerts, like how do you set monitors to alert on something, and then logging, and finally this is my personal favorite tool, Datadog. Um, so you can create a trial account there and start using Datadog also. There are some advanced tools and technologies that will make you stand out as an exceptional professional. These tools will set you apart and give you the edge in the competitive job market. It's like a bonus. Okay, so the first one is Helm. So it's a package manager for Kubernetes to deploy and manage applications easily. And then it's Istio. Istio is a service mesh for microservices. It helps in to enable traffic management, security, and observability. And finally, Flux and ArgoCD. So these two are also very important and now widely used in organizations. Remember, no one becomes an expert in everything overnight, and you should need to understand the usage of all these tools and technologies, but you don't need to be expert in everything. As you advance in your career, you will naturally gravitate towards the skill that align with your strengths and interest that will give you the opportunity to master them over time. All the best and kudos and congratulations.